In this video, we are going to discuss problem based on electric flux. According to the figure, a cube that has 5 centimeter side length in a uniform electric field E equals 200 Newton per coulomb that is perpendicular to the plane of one face of the cube. What is the magnitude of electric flux passing through the black face? So I want to find the electric flux passing through this face of the cube, which has a side of length A equals 5 centimeter, which you can write as 0.05 meter. The cube is placed in an electric field E equals 200 Newton per coulomb, and the direction of electric field is as shown in the figure. We need to find what is the flux through the black face of the cube. So we know from the definition of flux, phi equals E A cosine theta, where E is the electric field, A is the area, and theta is the angle between electric field and the area vector. So we can show the area vector for the black face of the cube. We know that area vector is always perpendicular to the surface pointing outward. So this is area vector A. And from the figure, we see that electric field and area vector are opposite in direction. That means the angle theta between them is 180. Area for one side of the cube you can find by taking the side squared. So we will substitute those values here. Phi will be equal to electric field is 200. Area is side squared, so 0.05 squared into cosine 180. So that gives me phi to be equal to negative 0.5 Newton meter squared per coulomb. So this is the flux through the black face of the cube. Next question. A 3.5 coulomb point charge sits at the center of a 1 meter cube. What is the electric flux through one side of the cube? So here in this question, charge Q is at the center of the cube and the value of Q is 3.5 coulomb. We need to find what is flux through only one face of the cube. Now, because of the charge at the center, there will be flux through the entire cube. And we can write this flux phi to be equal to charge enclosed over epsilon naught. That will be equal to Q over epsilon naught. Now, this is the flux through the entire cube. We need to find flux through only one side of the cube. A cube has 6 sides. So if this is the flux through the entire cube, flux through just one surface of the cube will be phi by 6. So this is equal to Q over 6 times epsilon naught. So let's substitute. Charge Q is 3.5 over 6 times epsilon naught is 8.85 times 10 to the power negative 12. And when you solve this, you get flux through one side of the cube to be equal to 6.59 times 10 to the power 10 Newton meter squared per coulomb, which you can round off to 6.6 times 10 to the power 10 Newton meter squared per coulomb, which is option A. Next question. A point charge sits in the center of a 1 meter cube. Flux through one side of the cube is 7.2 times 10 to the power 10 Newton meter squared per coulomb. What is the charge at the center of the cube? So here in this question, they have given us flux through only one side of the cube, which we will write as phi 1 equals 7.2 times 10 to the power 10 Newton meter squared per coulomb. Now this is flux through one side. A cube has 6 different sides. So the total flux through the cube, which we will write as phi, will be equal to 6 times phi 1. Now we know from Gauss's law, total flux through any closed object is numerically equal to charge enclosed by the object over epsilon naught. And this charge enclosed is nothing but the charge at the center of the cube. So we can write this as phi equals Q over epsilon naught. So we can find the charge Q by multiplying phi with epsilon naught. And this 5 is 6 times phi 1. So we get 6 times epsilon naught phi 1. Now let's substitute. Phi will be equal to 6 times 8.85 times 10 to the power negative 12. Phi 1 will be 7.2 times 10 to the power 10. And when you solve this, you get charge at the center of the cube to be equal to 3.8 Coulomb. So my answer is option A.